Okay, proper motion. A proper motion is the movement of stars that is caused due to the real movement through millennia. And for example, this is the Big Dipper. This is how it used to look from 100 years ago. And as you see, stars start to move from their positions to new positions. So proper motion is moving the stars of the Big Dipper across the sky. And after 100,000 years in the future, the Big Dipper will have a distorted shape. So this is caused due to the real motion of stars, and it's not like what we saw in the previous video in part 1, that was caused due to the movement of Earth. So it's totally different. So let's talk about the apparent magnitudes of stars and their absolute magnitudes. Stars do have luminosity, and their luminosity are like lamps. They are determined in watts. So a star luminosity is how bright it is. But if this star is very bright, but it is very far from the Earth, so it will be faint from Earth, and this is caused due to the light received, the flux received from the star. So if we have a bicycle like this having a small luminous source of light, and this bicycle is near to this woman or the observer, so the observer will receive lots of flux from the bicycle, but not much flux from the car. So the apparent magnitude, or what we see in the sky, does not really tell us much about the real magnitude or the real absolute magnitude and luminosity of stars. So the flux received from a star is L over D square, where L is the luminosity. So with distances, the light flux decreases. So if we have a star B, which is smaller in luminosity but it's near to the Earth, and a star A with higher luminosity but it's away from the Earth, they can both have the same brightness seen from the Earth due to the received flux. That's why we can see stars with different apparent magnitude, which is said to be the m small v. And the apparent magnitude is a number that is determined from positive to negative, and the more the positive, the less the brightness, and the less the number, the more the brightness, and the more the negative, the more the brightness. And the higher magnitude that you can see, which is the least brightness, is 7 magnitudes. Okay, so the absolute magnitude is different. The absolute magnitude is that you imagine that all stars are at a distance 10 parsecs from the Earth, and this way they will all, you will be receiving the same flux, the real flux, and not that is caused due to different distances. And this can be a function that can tell us about the luminosity of a star. you can determine a star's distance if you know the apparent magnitude and the absolute magnitude, and this can be derived from this relation m small v, which is the apparent magnitude minus the absolute magnitude, equals -5 plus 5 log the distance in parsecs. Okay, that's good. We have another thing, another relation which really relates the luminosity to the radius and temperature. So as the radius and temperature increases, the luminosity increases, and there is a big relation between all these three. So this sigma, by the way, is the Boltzmann constant, and so if you know the R and L, you can know the T, and if you know any of those two parameters, you can know the third. Okay, stars radii. Polaris has just about the same spectral type and the surface temperature as our Sun, but it is 10,000 times brighter than our Sun. Thus Polaris is 100 times larger than the Sun. This causes its luminosity to be 100 power 2, which is equal to 10,000 times more than our Sun. Okay, so why did this happen? Having the same spectral type means the same chemical composition, so they have the same temperature, Polaris and the Sun. But because there was a physical change, which is the diameter and the mass, so the luminosity was 10 times than our Sun. So there must be a relation that organizes all these parameters together: the mass, the luminosity, the temperature, the spectral type, the color index, the life of the star, everything. There must be a relation to organize them, and this relation is called the HR diagram, Hertzsprung-Russell diagram. In the next video part we will discuss it.